Okay. In this one, we're going to talk about some of those digital modes where upper sideband and lower sideband are different than normal phone. Some of the terms that'll come up is RTTY, which stands for radio teletype, um, which is essentially duplicating what they used to do with teletype machines back in the dark ages, doing it via radio or wireless, where teletypes were physically connected with a 20 milliamp current loop and sent signals back and forth. So it was a kind of electronic typewriters that were networked together. PSK31, which is one of the digital modes, which stands for phase shift keying as opposed to frequency shift keying. The 31 means it has 31 hertz bandwidth. It's a very narrow signal. And PSK31 is a keyboard to keyboard type communications. It's not voice. You actually type on your computer or possibly with a keyboard connected to your radio if you have a radio that supports that. Some do, it's not common. JT65 is another digital one that's part of the WSJTX suite of digital modes. It stands for Joe Taylor 65 because it uses 65 tone frequency shift keying. That's a lot of tones. FT8 stands for Frank Taylor. It's the same Joe Taylor, but there's another guy, and I forgot his first name, Frank or Frankie, however you pronounce that. And that's really the most popular digital mode. The 8 is it uses 8 tones in what's called audio frequency shift keying. There's a slight difference between audio frequency shift keying and frequency shift keying, where we might talk about that a little bit. Forward error correction, or FEC, where you send redundant information that's encoded along with the message, so the receiving end can detect and correct errors. Part of that is an ARQ protocol, stands for automatic repeat request. So if the receiving station gets a message and detects errors, they send back an ARQ which says to the transmit station, resend the message. And that can go on 2 or 3 times. And if it's unsuccessful, then usually the connection is stopped. And that's something that can be programmed as to how many retries. Typically, it's like 3 to 5. WinLink is another one of the modes. It's kind of a radio email system where you send email type messages, and it uses VARA and Pactor. They're both protocols that are used to send the information. Pactor is the oldest one. It's really not used that much anymore, and it required a hardware modem to do those protocols. And it sends packets or blocks of data that have forward error correction, and they support ARQ. So if there's an error in reception, The receiver can send back an ARQ message and they try to repeat it. And a message can be broken, if it's a long message, it may be broken up into multiple packets. You can kind of think of a packet as like a letter. So the data or the contents is inside the envelope, and the outside of the envelope has the header of who it's going to and who it's from. So packets are like that. They have a header which has that type of information, and they also have that checksum or some other code on it at the end. VARA is similar to Pactor, but it's a software protocol, or we call it a software modem. And that's what's typically used today instead of Pactor. And it does the same kind of thing. It sends the packets that are put together by WinLink. And it's essentially delivering mail and reading mail messages.
I have a quick question.
Okay.
Okay. Can you give me, you may have done it and I may have missed it. Can you give me an example of, what was it, FEC?
Forward error correction.
Correct.
Not easily. It's
I'm trying to understand what that actually means. Like what is that? What is the purpose of that?
okay.
What does it do?
An error correcting code. Trying to think how to explain this. If you take your data, say you have you're sending data in bytes. You've got 8 bits of data. You can generate what's called an error correcting code or error detecting code and append that code to those 8 bits and send it as a message. So in the simplest form, which would be error detection, would be to append a parity bit. So you look at those 8 bits and add them up to see whether or not the result is odd or even. So if your protocol is to send odd parity and your 8 bits is even, then you add a 1 to the end to make it odd. So the receiver kind of does the reverse and makes sure that it adds up to odd. Otherwise, there was a bit error.
Okay, so it's not like an autocorrect, like your spelling correct or anything like that. It's not correcting the message sent. It's correcting the number calculus and the data.
Well, no. Like I said, that was error detection.
Okay.
For error correction,
yeah,
you have to append a longer string, okay, which I'm not going to go into how those are generated, but
that's okay. I'm just trying to understand. So when
you
I
can
get
actually you can generate a code which the receiver can use to determine if any of those 8 bits is in error.
Okay.
Typically, it can, a short one can only detect a single bit error and correct it. If you have 2 bits in error, it may or may not be able to correct it.
Okay.
And
so if
you do a longer error correction code, you can detect and correct more of the message bits.
Okay.
So those typically in something like, say, FT8, you'll have a text string that's encoded in binary octal. And then you'll have your error correction code appended to it. And then that whole thing gets encrypted and sent. it's kind of a complex process when you talk about things like the digital modes like FT8. And part of that is because it was developed for deep space communications where you're talking to satellites and probes that are, out past Pluto.
Mm-hmm.
So you're talking about extremely weak signals. And that
Okay.
was adapted by Joe Taylor into these amateur radio modes. He
Okay.
actually got, uh, I think he got a Nobel Prize for doing the deep space stuff.
Okay. So it can determine whether your signal dropped off and it didn't get the full message. It's kind
Right,
of, yeah.
right.
Okay. Understood.
Okay. Um, so let's see. What are we doing here? Digital mode. Okay. The 14 on 20 meter band, the 1407 to 112 is typically where all these digital modes are. FT8 and FT4 and RTTY and all those things. Um, and PSK is also in there. Actually, I'm going to have to try PSK sometime. I haven't actually done it. Um, and it's not part of the WSJTX suite. It's because it uses phase shift keying as opposed to frequency shift keying. And even though you don't need it for the general, on the frequency shift keying, like for FT8, and they call it audio frequency shift keying. What you actually do is you set your frequency, transmit frequency to 14074 on 20 meters. And you're transmitting upper sideband. When you actually send data, okay, depending on where you want to transmit within that 3 kilohertz upper sideband, you're sending a set of uh, 8 tones that are within a 50 hertz bandwidth. In other words, each tone is 6.25 hertz. So those 8 tones represent a symbol of a state of uh, 3 binary bits or 8 states. So you see that little 50 hertz thing. If you look at the waterfall display, you see this little block somewhere in that 3 kilohertz band. So it's actually an audio tone or set of tones that are offset from the carrier somewhere in that 3 kilohertz band, as opposed to actually shifting the frequency of the carrier. So the carrier stays fixed, and you send tones that are offset by wherever you are in that band. Is that make any sense, or does
Confusing,
confuse you
yes.
more?
Confusing, yes.
Okay. Um, we'll probably talk about it more later on. And then the 80 meter band, uh, there's that little sub band that's down there where a lot of that is. Like I said, FT8 has been the most popular. Uh, there's been more activity on FT4 because it's essentially twice as fast, where FT8 transmits uh, over 2 time slots that are 15 seconds each. So it receives during the first 15-second time slot, and it transmits during the second 15 seconds, and then it repeats. FT4 does 7.5-second time slots. So you can make a contact twice as fast on FT4. They've recently, some Italians have come up with FT2, which does uh, what, 3.75 seconds. It's even twice as fast as FT4. It's because it's only doing two tones. It isn't nearly as sensitive. In other words, you can't pick signals out of the noise like you can with FT8. FT8 is capable of decoding signals that are as much as 24 dB below the noise level, which is absolutely amazing. I mean, you can't hear the signal and it can decode it. Uh, in most of these modes, like FT8, okay, when you make a contact, it's going to exchange your call sign, your grid locator, and part of a signal report. Basically, it just gives you your signal strength. It doesn't do tone or readability. What else can I say about it? Oh, in order for it to work, you have to have, since in most cases you're using a computer to do the decoding and encoding, uh, your computer needs to be time synchronized within a second of absolute time. So in most cases, if you're serious doing some of these modes, you may have your computer linked up with at least one of the time sources, like the NIST one, or have a GPS input, so you're synced with GPS time, so that you maintain within that 1 second. It's preferable to be within like a tenth or 2/10 of a second, because the farther off you are, the harder it is for the software to decode a signal.
Hey, Bob,
Yes?
what does it mean, the noise floor?
Okay. If you turn on your radio, uh, tuned any place, if there's no signal there, you're going to just hear what sounds like static. That's noise.
Uh,
It's coming from a lot of sources. A lot of it is background radiation from the Big Bang. Um,
so when you're
and
tuning the radio, it's going. That's the noise floor.
well, it sounds more like frying, I'd say more like frying bacon or something.
Bacon.
And if you look at it, if your radio has a spectrum and a waterfall display, I mean, you see that little kind of fuzzy spectrum line, and it'll be down. If you got a really good radio and conditions are right, your noise floor might be down, you know, maybe 100, 120 dBm. So when you're trying to listen to a station or signal, let's pick FT8 because it's only 50 hertz wide. Normally, you do FT8 and you're listening to a 3 kilohertz bandwidth uh, offset from wherever your carrier is, like 7074 on 20 meters. So you've got a 50 hertz signal within that 3 kilohertz. The 3 kilohertz is picking up 3 kilohertz of background noise, which is added in to that 50 kilohertz wide FT8 signal. So your signal to noise ratio is kind of the ratio of how strong that FT8 signal is to the total strength of that 3 kilohertz bandwidth. if you were to shrink the 3 kilohertz, which you can do on your radio, you don't have to listen and decode all three. If you're trying to find a particular station, you can narrow your passband down on most of the better radios to, 100 hertz or so around that FT8 signal. So now your signal to noise ratio is that FT8 signal compared to maybe 100 hertz of noise. So it's much, much better. The amazing thing about things like FT8 is when you see that noise, you can have a signal that's as much as 24 dB below that noise floor. You'd never see it. It'd never show up on a waterfall. And you could decode it.
Holy cow.
In theory. In most cases, I don't think I've ever been able to make a contact below like minus 15. But even that's amazing. And, when we talk about dB, minus 15 dB is about a 40th of the noise signal. Means the noise is 40 times stronger than the signal. Okay.
Thank you.
FT8, FT4, all those transmit on odd and even time slots. So they're synced with time. So, and you have the choice when you bring up like FT8 of whether you are transmitting on an odd or an even time slot. So the protocol is that you receive and then you transmit. So when you receive, you're listening to people that are transmitting on the time slot you're receiving. So if you're doing odd, then obviously they're doing even, and that's why you hear them transmitting when you're receiving, and vice versa. When you transmit, they're in receive mode. If you were both on odd, you'd both be trying to transmit at the same time, and then you'd be listening at the same time, so you'd never hear each other. So that's why you try to pick a time slot that's not only empty, because you don't want to transmit on top of somebody, but you want to transmit on one that's the opposite of the station you're trying to listen to or find. Like I said, FT8 uses a 30-second window, 15 seconds for receive and 15 for transmit. Now, technically, it's about 12 and a half seconds. So there's a few seconds extra in there for it to do its thing. But it still takes 30 seconds to do the transmit and receive. You'll see most of the excuse me, go ahead.
Oh, I'm sorry. I just turned my mic on. I was going to ask a question when you got done.
Oh, most of the activity you'll see would be on 20 meters and 40 meters on the 774 to 777 and 1474 to 1477. So those are 3 kilohertz upper sideband bands that it transmits. And you notice 40 meters is still upper sideband. Even though if you were doing phone on 40 meters, of course you wouldn't be doing phone down that low, but you would be doing lower sideband on phone. What's your question?
Okay, so we're talking literal time. So if I just happen to come in and we're looking at the 10-second, at the second intervals. So 10 seconds is even, 11 seconds is odd. For me, going into if I opened a channel and I'm receiving, I'm receiving either on an odd second or an even second, correct? When you're saying odd and even time slots, are we talking about seconds? Or are we talking about minutes? Are we talking about
Uh, let's see.
because I'm thinking the way I'm reading it is if it's coming in seconds for transmitting and receiving, if I open a channel and I receive something, it's going to be on the odd or even seconds. And that's how
Okay,
I would be able to
right. But remember, the time slots are 15 seconds.
right.
So
So
it's an odd or even 15 second.
right. So say I opened something and I got one, I was started receiving it on the 12 seconds, whatever time in 12 seconds.
Okay, well, all right, 12 seconds. And at zero,
Even.
okay, 0 to 15 seconds. Well, let's make it on an even minute.
Okay.
The first 15 seconds, you might be in receive mode, and then you'll be in transmit mode. Okay.
Okay. I was just trying to figure out the odd and even time slots.
And
what
that
are we
would be
focused on? What are we
that
focusing
would that would be transmitting odd.
on?
Okay,
Okay, so
because
0 to 15 is odd.
you're doing, well, let me see.
So that's what I was trying to figure out. Like, how do I determine if I'm odd or if I'm even?
Well, to keep from overthinking is simple. You check the button transmit odd or even.
Oh, so it'll determine it for you.
Yes.
Oh, I
You
did not know that. Okay,
you
that's
can
why. Okay,
you
okay,
can select that.
okay. Did not know that. All right.
I honestly I'm not sure I really know how they define odd and even.
Yeah, because I was trying to figure out if I have to determine that, what do I use as my guide to determine that?
The
But
bottom line is
hit that
if
switch.
if you're if you're one or the other, say you're odd,
Yeah,
okay, it means that they're receiving when you're transmitting,
right.
and you're transmitting when they're receiving. And
Correct.
if you switch, it's
Yeah.
just, it's the
I can
same deal. It's just different time slot.
all right. So it's not necessarily an odd actual physical time slot or an even actual physical time slot. It's just saying you're either receiving or transmitting, not both at the same time.
Right. As
Okay,
long as you're not doing both at the same time, you're good.
okay, because I thought we were actually determining what time is a time slot. An odd time slot is what time, and an even time slot is what time, and that's where I got confused.
Oh, yeah. Yeah, you don't need to worry about that.
Okay, gotcha.
Okay. This is what a blurry FT8 station looks like. And you notice the waterfall up there. And each of the little bars uh, is basically a 50 kilohertz wide transmission. And there's not much of the spectrum down at the bottom that you can see. I normally have mine with the spectrum above the waterfall, but you can see kind of those signals. Um, in this case, they're strong. When you see them colored, yellow or orange or red, it's a pretty strong signal. When they're down in the blues or getting down to a dark blue, it's a very weak signal compared to the black noise background. And in this case, let's see, right here in the middle, see this TX even / first, where my cursor is, if you can see that.
Yeah. Oh, yeah. Yeah.
Okay, that determines whether you're going to transmit even or odd. If you check it, you're going to transmit even, which means you're transmitting in the first 50-second time slot.
Thank you for clarifying that.
There's also another one here, hold TX frequency. If you check that, then whatever frequency you pick to transmit on, and you need to find one of these black empty spaces. This is kind of a busy FT8. That would fix your transmit frequency. In normal operation, you see one of these stations is being decoded, and over here is the message window. These are all stations that are being decoded, and it's showing you their signal strength over here. So you're seeing some plus numbers and some minus numbers. There's a minus 10. But they're also receiving you at plus 8. So this is what they're reporting. Okay. And if you want to make contact with one of those, like a directed contact, you just double click on it and it will populate your little message box down here so that you'll go through the protocol and you'll send, instead of sending a CQ, you send a directed message to that call sign. And if they reply back, then you jump down another one, and then you reply back to them. You're sending call signs and signal reports back and forth, and then you finally get an acknowledge with a 73 with an RR, which is like a Roger Roger 73, and then you finally complete. And if normally it's set up so automatically when you complete a contact, and this is all done by the computer, you can just watch this. It will pop up this little log window where you can fill in some extra information. It'll have the call sign, what mode it was, what band it was, signal strength, both sent and received. You can add additional information like, how much power you were using, some comments. You can put your operator call sign or name, something like that in there, and click OK, and that goes into a log file. And you can then later take that log file and send it to Logbook of the World or QSL, some of those, and actually get credit. And you can get awards for, doing all 50 states, doing 100 countries, a bunch of things like that. Doing it on different bands. There's a ton of different awards that you can do, not only with phone type stuff, but with the digital modes. That's probably more than you need to know for the exam on FT8, but that's typically what it looks like and how you would work it. The ones showing up over here are ones you're actually communicating with. Any questions on that one? Okay.
This is probably pretty basic, but I'm kind of new at all this. But how do you access the WSJTX software? How do you get to it? Is it strictly a Windows thing, a Linux thing? What is it?
It's available for Windows, Mac, and Linux. You just Google WSJTX and download it for whatever platform you have.
Okay. All right. Thanks.
It's pretty simple. You have then, once you have the software installed, you have to configure it for your radio and also make the appropriate connections. I think there's a slide coming up about that a little bit.
Okay.
RTTY is another one of the digital modes. Been around a long time. I guess it's been a little more popular. They do have some RTTY contests, the ARL does. And some transceivers can actually send and receive RTTY transmissions without using a computer. Excuse me, they must be back with the pizza. Hello. All right, bye. Okay. We talked about RTTY being different in that it uses frequency shift keying, where you're actually shifting the frequency digitally because you're sending ones and zeros. This is a digital mode. And they call sending a 1 a mark and sending a 0 a space. And typically, RTTY is going to transmit on these two frequencies. Well, it's going to shift to these two frequencies between 2125 and 2295. So that's the mark and the space. They're 170 hertz apart. That's the 170 hertz shift. So you either send nothing or you send, you're sending the carrier and then you're either shifting it to 2125 hertz or 2295 hertz. On 20 meters, you normally would be operating in that 14080 to 14099 kilohertz range. It's different on other bands. The ARRL actually sends out bulletins from W1AW, and you can go to their website and find out what the schedule is. They send out bulletins, I don't know, I think it's several times a day in RTTY. So if you can do it on your computer or your radio, you can actually tune there and decode it and read the entire bulletin, which is usually stuff about propagation and solar activity, things like that. This is actual RTTY decoding on an ICOM 7300. It has a built-in decoder. And you see this little, over to the right, those two bars, even though this appears in, I guess, transmit mode, normally you'd see this signal, and it has kind of a bar on either side of it, which isn't shown here. And you try to tune it to where you have that RTTY signal centered between these two bars. And when it's perfectly centered, you'll see this little indicator up here, which is in the middle right now. And if you're off, it'll either shift to the left or to the right to show you whether or not you're decoding, you're centered. So the closer you are to having it centered, the better it's going to decode messages. Now, in this case, since there's really no signal there, it's just decoding noise, which is why it's not readable. So that's what you see before you actually tuned in a RTTY signal. There's also some computer programs. There's one called Gritty and I think there's a NITY or NTTY, something like that. There's several of them that will actually do decoding on the computer if your radio doesn't have the capability to decode it. Okay, to do most of these digital modes, unless it has the capability built in, you normally have to use your computer. And you have to connect it between your transceiver and your computer, either with audio cables or a USB connection. It depends on your transceiver. Most of the modern ones will have what they call a built-in sound card, the ability to detect and generate audio tones, and have a USB port. So you can make a USB connection between the computer and the radio, and it will generate virtual audio transmit and receive signals, as well as cat control and push to talk. If you don't have the capability to do it USB, you have to physically connect your microphone input on the computer and your speaker output to the mic input on the speaker, to the mic input on the radio, and the speaker output on the transceiver to your mic input on the computer, and also a connection to do push to talk. The computer, or in some cases, you could have a transceiver that has a built-in capability to do things like FT8. It's not common, but they're there. The computer, wherever it is, whether it's in the radio or it's external, is generating that audio frequency shift keying signal, or those 8 tones that are used in the case of FT8, 4 tones in the case of FT4. Like I had mentioned earlier, these are kind of exceptions where RTTY, which is doing frequency shift, is using lower sideband regardless of the frequency, and the FT8, the frequency shift modes are all using upper sideband regardless of the band. This is kind of showing 2 possible connections between a laptop and a transceiver. So you're either going with an A to B type USB cable, which is typically the way it would hook up, or your mic or line in and your mic or line out, depending on how they're labeled on your computer or laptop, to whatever the input ports are on your radio. It may be through this like accessory connector on the back of this one, or they may have separate phone miniature phone jack ports. Depends on the radio and what you need to connect it up. If you're trying to do a radio that, say, doesn't have a sound card, then you need a little external device between your computer and the radio, which has this virtual sound card in it, which can interface between the two. There's a thing called DigiRig, I think is one of them. There's another one I can't remember the name of right now that are kind of popular, typically used. They're not too expensive, and they're set up so depending on the cable between that little box and your radio, you can get them to work with almost any radio. If you got a more modern radio, like a base type station, um, probably has a sound card, and you can probably do the USB connection, which is definitely the simplest. Once you have it connected physically, however you do it, then you have to go into, say, the WSJTX software and tell it what your uh, transceiver is. Have a drop down list and you pick your rig, whether it's, say, an ICOM 7300 or a Yaesu something, or you pick the one it is. Then you go over and you pick your audio transmit and receive virtual ports, select those. You usually have to do that by going to your um, computer's. I'm having one of those brain farts.
Settings?
No, and I was just doing it before we started, where you can look at all the ports on the radio, and one of those is the LPT ports, and you'll have to find which one of those your radio is generating if you're using USB, and select that for your um, CAT control, which means the ability to control the frequency of your radio, where the computer actually can change the frequency, and push to talk, where it can turn transmit on and off. And then the audio ports, like I mentioned, are also listed up there under your audio section. And you have to find the ones that are coming from your radio. Usually you do it by turning the radio on and off and seeing which ports pop up and go away. And there is a way that you can actually go into the computer and label those.
In device manager, you're talking about?
Excuse me?
Are you talking about?
Yeah, device manager is what I was trying to think of. There is a way you can actually go in and change the labeling on them so that you can remember them, and you can label it like 7300 or whatever it is, in and out, instead of having to remember that it's port 6 or port 7. um, However, once you've got it set up and configured, you shouldn't have to go change anything. Okay. That's probably more than you needed to know for now. When you're doing some of these digital modes, some of the problems, if you are not able to decode it, like for RTTY or other FSK signals, some we hadn't talked about, your mark and space frequencies might be reversed. That's something that I think you can do in your computer program or on the radio. I know on some of mine, you can do a reverse mode. It'll be a -R after the decode mode, which swaps the frequencies around. So that may be wrong. In the case of something like RTTY, you have to pick the right baud rate. So if you got the wrong baud rate, you're not going to decode. If you're listening to upper sideband trying to do RTTY, it's not going to work. Even if you tune the signal and it's in your upper sideband space, everything's going to be reversed, so it won't work. WinLink is an older digital mode. It's still around. And it uses the internet to talk to other stations and deliver the messages. So it's a message and data, kind of an email type server. And the stations that it connects to get to the internet technically are called remote message servers. we tend to call them gateway stations. So on the exam questions, it'll be a gateway station. And the gateway station is looking for a specific frequency. So you have to tune to that frequency and transmit a connect message to the gateway to actually connect. And that makes a peer-to-peer connection. It's not a broadcast type. So once you make that connection, it's essentially private between you and whoever you're talking to via the internet.
Hey, Bob?
Yes.
I was talking to someone the other day and I said, it seems like it's possible now to do ham radio without actually having a radio. And they said, there's a radio in there somewhere. And I was not willing to argue with that point, but this sounds like you can do ham radio without a radio on that prior slide. Is that true?
No,
Anywhere,
you're
there's a radio
using,
somewhere.
yeah, you're using the computer to control your radio, and your radio is connecting to the gateway. From the gateway on, it's over the internet, but it's the radio between your transceiver and the gateway. That's why you have to tune to the published frequency for that particular gateway.
What is the gateway like? If you drew me a picture of it, would it be a repeater like thing?
Well, you could think of it like a repeater, although instead of repeating your signal out on a different frequency like a repeater would do, it's just taking your signal and interfacing it
To
through
make
the
it
internet.
radio waves.
So you're converting radio to internet protocol in the
Okay,
gateway.
so
Well, think of,
theoretically, couldn't you have that happening on your computer? I mean, I've got internet coming into my computer. Can I have the computer do that job that the RMS is doing? I mean,
well,
theoretically,
technically, yeah, theoretically,
then it
but
wouldn't be a ham radio, right? It'd be something else.
well, no, but I mean, if you had your computer set up as a gateway, if you got it registered as a gateway, yeah, you could do that. But you can't just, first of all, the gateway has to be able to has to have a modem, an RF modem, so that it can receive an RF signal. Here, let me give you an example. I'm not sure if you're familiar with them. There are things called hotspots.
Yes.
Okay, now I'm not talking about setting up your cell phone to use as a hotspot.
Okay.
I'm talking about a hotspot for digital voice, things like D-Star, DMR, Fusion. And these are little devices. Typically, it's something like a Raspberry Pi Zero. It has a little RF modem card attached to that Raspberry. And it can operate in, let's say, I have one set up for D-Star on a particular frequency. So I can take my D-Star radio and set it for that frequency for my hotspot and talk to that, make a link to that hotspot, which is also linked to the internet through my Wi-Fi connection. Or it could be an Ethernet connection, could be direct. So it's converting the RF signal from my handy talkie or my base station, which is digitized voice over RF, into a digital signal sent over IP protocol through the internet to another D-Star repeater or hotspot somewhere, which is connected via RF to another radio.
So
So
the
I'm
question
making a
is,
connection between my radio and a radio somewhere else in the world, but internet is in the middle.
so we'll say that a radio is a device that generates radio frequencies.
Right.
That's it.
That's it.
No antenna or anything. You take all that out of the picture, but there has to be something somewhere that's generating and then decoding radio frequencies.
Right. And that's what the gateway does in the
Yep.
case of WinLink, okay, and using VARA or Pactor. Oh, it's taking the RF signal, which is actually being generated by your computer, okay, telling
Decoding.
your radio, it's
Yeah,
being
yeah, yeah,
encoded in
yeah,
the radio
yeah.
to send it RF to the gateway.
I understand. Thank you. I'm
Okay.
good. Yep.
Okay. Now there are other modes which we talk about in the extra. There's things like Echolink, where you use your cell phone to possibly talk to a radio in the internet. There's IRLP, which is Internet Radio Linking Protocol, which you're using your radio to link to kind of like a gateway similar to what WinLink does. Remember, WinLink is data text mode, where IRLP and what I just said the cell phone was, are voice. Now they can also send data. In fact, I can use my cell phone to connect to my D-Star radio to send pictures, for instance, in parallel with actually making a voice contact. So I can be talking to somebody over in Europe and at the same time send them a picture using D-Star. So we're going over the radio, through the internet, over the radio, and doing
Oh,
voice and image
image.
at the same time.
Image over the radio.
Say that?
Over the internet. Image over the radio.
It's going over the radio and it's going through the internet.
Wow. All right. Back on track again. Thank you.
Okay. Let's see. Pactor uses error correction. Okay. Like I mentioned before, once you make a Pactor connection, whether using WinLink or something else that uses Pactor, because it's a protocol, it's a peer-to-peer. So it's only a connection between those two stations. You cannot, it's not a party line, let's say. You can't break in or essentially listen to that transmission. We talked about if you have an interference problem, that's where the ARQ type protocol comes in, where you do a retransmission. And after so many retries, it just breaks the connection and gives up. You can, I can't say I've ever done this. Actually, I've never done Pactor because it requires a hardware modem. Not many people use Pactor anymore, and I suspect this may go away in the next question pool for general, but I'm not sure. Sometimes they keep stuff around for a long time. I think on this next one, you can actually get a mode where you can monitor whether there's communications going. You can't necessarily decode them, but you can tell whether there's a connection in progress, so you know that it's busy. So if it's busy, there's no sense in trying to make a connection because it's not going to happen. And that's basically this last one. You're limited to 2 stations at a time.
Question.
Yes.
It says you cannot connect 2 Pactor stations together. So if somebody else is using Pactor, you can't connect to them.
You can't connect to that Pactor station, yes.
So you wouldn't be able to commute with them at all.
Well, it's like you've got a cell phone connection to somebody.
Right.
Okay. This may not be a good example because there's other ways to do it, but if somebody else tries to contact you or the other person, they get a busy signal.
Right.
It would be the same kind of thing.
So if somebody else is using Pactor, you can't connect.
Right.
Okay.
To that gateway.
Okay.
Now, there's more than one gateway.
Okay.
They're on different frequencies.
So you would have to find them on a different frequency.
Yeah.
Okay, understood.
Okay, mesh networks. This is something that's becoming more popular, where it kind of started with amateurs taking a commercial Wi-Fi router and loading different firmware on it, so they could create this mesh network and use multiple of these routers. And part of the firmware that they load has this mode where it can go out and search for other stations, and if it finds one, make a connection with it and build up this mesh network, so you can have multiple of these stations connected together through various paths, so you have a redundant network. So if any one of these stations fails, there's probably at least one or more ways to go through that network to get from point A to point B. They normally are operating in the 5 gigahertz, which was the cell phone 5 gigahertz band, or the Wi-Fi band also, and up at 10 gigahertz. Recently, they've developed this thing called AREDN, the Amateur Radio Emergency Data Network, which is specifically set up for emergency purposes. So it's a redundant network. In other words, it's fault tolerant, so that you can do emergency services. Even if not all the stations are up, you've got a pretty good chance of being able to get from point A to point B. Here's a little diagram of one of these mesh networks somewhere out in Colorado. You might recognize some of the towns. Like Breckenridge is where I used to ski. Cheyenne, that's probably Wyoming. Oh, San Antonio, New Mexico. Wow, that's a pretty big network.
So there's
like I said,
There's
these are getting quite popular. I know there's some clubs over in Orlando that have a fairly large one.
It seems like somehow there are still some critical points in there that you have to go through, you know,
Well, there could be. It depends on,
the
your
configuration.
mesh,
Yeah,
right?
yeah,
If you didn't have enough stations, you could have a single point failure.
yeah.
The whole idea is have enough so that you have multiple pathways. Which is kind of the way the internet works. Your router normally has multiple paths to get to from point A to point B. Okay, which mode is normally used when sending RTTY via AFSK with an SSB transmitter? I think I misspoke before. I said RTTY was FSK. It's AFSK.
Delta.
I think I said it was PSK. It's not. So anyway, which mode?
Is DSB actually a mode? Digital sideband or something?
That would stand for double sideband,
Double side, of course it does, sorry.
where it's a mode where you suppress the carrier, but you send both sidebands. It's not the correct one, but it's a real mode.
Well, if somebody will guess alpha, I'll guess delta.
Delta.
It's delta.
Yay!
What is VARA? Don't overthink it.
Bravo.
Right. What symptoms may result from other signals interfering with a backdoor or WinMore transmission?
Delta.
Delta.
Good. Which of the following is good practice when choosing a transmitting frequency to answer a station calling CQ using FT8?
The alternate time slot, the D, delta.
Yes.
Yes.
And a
Delta.
clear frequency. That's important.
Frequency, yeah.
What is the standard sideband for JT65, 9, FT4, FT8, FT2?
Bravo.
Alpha.
Yeah, Bravo.
Oh, there you go.
Upper sideband. They're always upper sideband on those. What's the most common frequency shift for RTTY emissions in the amateur HF bands?
Bravo.
Bravo.
Now, you don't have to do 170, but that's kind of the standard. Which of the following is required when using FT8?
Bravo.
Bravo.
Did I hear an alpha?
Bravo.
Bravo.
I kind of thought an alpha, but I wasn't going to say it.
Well, it would have been wrong.
Yeah, there you go. I was right that I was wrong.
In what segment of the 20-meter band are most digital mode operations commonly found?
Delta.
Delta.
Delta, yeah. The lower ones.
How do you join a contact between two stations using the backdoor protocol?
You can only do two, so Charlie.
Charlie.
Charlie, yeah.
Can't do it. Which of the following is a way to establish contact with a digital messaging system gateway station? Well, that's a wordy one.
Delta.
Delta. You have to connect to the gateway. You do a similar thing with D star and DMR, where in D star you link to the gateway or the D-star repeater, and also to a, they call them reflectors in D-star, they call them talk groups in DMR. And we'll talk about those a little more down the road. What's the primary purpose of an amateur radio emergency data network, Aridan mesh network?
Charlie.
Charlie.
Which of the following describes WinLink?
Delta.
Alpha. I like
yeah,
alpha.
Delta.
We'll go with
shoot.
Delta. It does all of those things. It sends packets and it sends and receives email, and it's wireless, and you can use it at VHF. There's a VARA FM modem.
Bravo.
Bravo. Yeah.
What could be wrong if you cannot decode a RTTY or other FSK signal, even though it's apparently tuned in properly?
Delta.
Delta.
Which means you got it between those two bars, but you're not decoding.
Right. Delta.
Delta. Yeah.
So many things.
Which of the following is a common location for FT8?
Charlie.
Charlie.
All right. All right. You guys did really good today.
I have 3 quick questions.